Hi, good day to everyone. Today we are going to learn LU4. The title is Sequence and Series. So within our learning unit contents, we will include 4.1 to 4.5. So for this session, we will focus on sequences and series. 4.1. So what is sequences and series? First, you need to know what is the meaning of sequences and series. Okay, let us go through the idea one by one. So learning outcome for this 4.1 is at the end of this unit, students should be able to use an explicit or recursive formula for a sequence to find successive term. Okay, there's a lot of new term here. We have explicit, we have recursive, we have sequence and successive term. All these are something new term for you. And then what is sequences? So sequences, a sequence or progression is an order set of number which can be generated to form a rule. Okay, example, we used to learn sequence like 2, 4, 6, 8, 10. Okay, so this kind of sentences, mathematical sentences is actually called sequences. It is a set of number formed by a rules. Okay, so formed by the rules. So the rule may give general term or R term U as a function of R such as, okay, this is how they write it, 1, 2, 3, UR is equal to R, okay? So let's see, okay, 3, 9, 27, and then this one you can see from here. So this is the formula, okay? This is the formula, so 1 over 2, 1 over 4. So we're looking at one by one. Let's say 1, 2, 3. Okay. How do we get the idea as in if this is a first term, the U first term is same as number 1. And then U second term is also number 2. And U3 means that the answer is 3. So this is a simple sequences. How about this one? This one, right, is U1 is equal to 3 power of 1. U2 is equal to 3 power of 2. U3 is equal to 3 power of 3. So you can see this power here is same as the term here. We call it the term here. So the answer here will be 3. Power of 1 is 3. 3 power of 2 is 9. 3 power of 3 is 27. So you can see this one is determine the number of terms. Okay. So this is the rules that found from these sequences. Okay, sequences. And then for this question, the formula for this one is, example, the first one, this one is U1, U2, U3. So let's see if we go for U3. U3 is equal to 1 over 2 power of 3 minus 1. So 3 minus 1 is 2, 2. So the answer is 1 over 4. So that's why the answer for third term here is 1 over 4. Okay. So this condition is called sequence. Okay, it's called sequence. And then how about series? There's a difference between sequence and series. As in series is the sum. Sum is called addition of the terms of the sequence. So they actually have a relationship. Just now, as we mentioned just now, as is sequence is example 2, 4, 6, 8, 10, and so on. How about series? If I want to use the same number, it will be 2 plus 4 plus 6 plus 8 plus 10. So the answer that you found here is actually the answer for series, which is sum of all the term of a sequence. Okay, such as this one, 1 plus 2 plus 3. That's now the first example. The second example, 3 plus 9 plus 27. The third example is 1 and 1 over 2 plus 1 over 4 and so on. Okay, so when you put plus, like this. This is example of sum of all, okay? So the Greek letter sigma, okay? I'm sure you ever heard of sigma. This sigma is different from the sigma legend that normally people talk about this. Okay, this sigma is a mathematics sigma. Okay, so sigma is used to write a series when the general term of sequence is known. For example, the sum of the first six term, the sum of the first six term of the following sequence. So if we want to, if it's given like this, 1, 3, 5, 7, 9, 11, where R is equal to 2R minus 1. Okay, so let's say this one is your U1, U2, U3, U4, U5, U6. So now let's say I go for U5 is equal to 2, 5 you put here. So it will become 10 minus 1 is 9. So U5 is 9. Is that true? Yes, U5 is 9. Based on this one, U5 is 9. But if they said write a series for this one, so it will be written like this. Okay, so let me explain one by one. So how many terms do we have here? 1, 2, 3, 4, 5, 6, 6 terms here. So this is the formula. Okay, formula. And then this one is R equal to 1. So start from 1. Okay, start from the first one. Alright. So to be more precise, number are placed below and above sigma to show where the series begin. Where is the series begin and when there is end? As just now you can see, okay? Generally, you can see this one. This one below is when it begin and then when it will end. Okay, so this one is the formula for the whole entire series. Okay, so the R term of the R is stand for R term. Okay, so example number 1, it is given that the n term of a sequence is un equal to 5n minus 2. Write down the first 4 term. Okay, so let's try one by one. So let's see the solution. So u1 is equal to 5. You substitute it with 1. Okay, if let's say here is 1, you substitute this one with 1. If this one is 2, substitute with 2 and so on. Okay, you continuously do this one. After you substitute with 1, 5 times 1 is equal to 5. 5 minus 2 is equal to 3. 5 times 2 equal to 10. 10 minus 2, 8. 5 times 3 is equal to 15. 15 minus 2 is 13. 5 times 4 is 20. Minus 2 is 18. So this one is the first 4 term. 1, 2, 3, 4. So that's why the answer is 3, 8, 13, and 18. Okay? So this was example number 1. So we have to write down the sequence is 3, 8, 13, 18. Okay? Let us recall back again. Sequence is what? It's a number. Okay? A number like this. Okay? A number. This is called sequence. So the first 5 terms of the following sequence. Okay? So it's given. This one is a formula. Un equal to un minus 1 minus 2 un minus 2. So this question has special as in they give you the condition as u1 is equal to 7 and u2 is equal to 2. Okay, so given that u1 is equal to 7, u2 is equal to 2. Let us think about it. What should we do? All right. So since u1 is equal to 7, u2 is equal to 2. So how about u3? u3 equal to u2 minus 2u1. So this u2 we substitute by real number 2, and then this u1 we substitute by 7 as given by the question. So 2 minus 14 is equal to negative 12. u3 minus 2u2, okay, so it will become u3. What is your u3 answer? Here we go. This is u3 answer. You bring forward here and then minus 2. What is your U2? Okay, here is your U2. U2, and then you substitute it, become negative 12 minus 4, become negative 16. Again, once you get this answer is U4. U4, bring forward, you get negative 16 minus 2, bracket negative 2. Where do you get this one, U3? It's from here, okay? So you can see that the answer that you get in the first row here is continuously bring forward and so on. You get your answer, final answer. This one is add. So if you want to write the first 5 term, this one is provided. So U1, U2, this one U3, U4, U5. Okay, this is how we solve the question based on the condition given. Okay, so the sequence is 7, 2, negative 12, negative 16, and 8. So now, write the following as a series. Okay, do you still remember minutes ago we studied the meaning of series? Series means you have to sum all of the number. Okay, example, what is this? What is the number that represent here, and what number represent here and here? As I mentioned just now, this one will represent where do they begin and where do they end. Okay, example 2. Okay, let's see here. 2 plus 3 plus 4 plus 5, because they will begin. So this one represent when do they begin and then where do this thing end. So 2, 3, 4, 5. They end at 5. Okay. So how about this one? Write the following as a series. Okay, so this one is begin, the one is the end. So you can try to, okay, when R is equal to 1. So you start with R equal to 1, and then U1 is equal to 2 minus negative 1. R is power here, and then 1. So you get the answer is 3. Continue when R is equal to 2, and then you continue to find the answer. The answer is 2. When R is equal to 3, you substitute it, become 9. R equal to 4, R equal to 5, R equal to 6. Okay, you do this one step by step. Just write out all your working steps. After you found the answer here, then you start to find the series. Mean that the number you plus all them together. Just show that plus all them together. No need to find the final answer. This one is already the answer because you just need to write it in series. Okay, so remember, series is just one sentences, mathematics sentences. We come with addition. Okay, so here we go. You rewrite by using this formula. Okay, actually this one should put at the bottom here. Should add this. Okay, sigma R equal to 1. Okay, 2 minus bracket minus 1 R. Okay, R, and then is equal to 3 plus 2 plus 9 plus 4 plus 15 plus 6. Okay, so this will be your final answer. Write the following as a series. So you look at this and then write in a series like this. Okay, remember, this one is start with 1, end with the 6. Okay, 6. So the one answer is 3, 2, 9, 4, 15, and 6. Okay. So now, here we go. We have tried example already. Now we go for exercise number 1. Find the first 4 terms of sequence whose n term is given by un is equal to 32.6 n. Okay. Next one, find the first 4 term of the sequence which is defined by un plus 1 equal to 2, un plus 1, n is greater than or equal to 1, where u1 is equal to 1. Write down the series of the following number. Okay, so you can see from here. So the answer is provided here, but I will explain one by one. I'll explain one by one. For the first 4 term of the sequence whose n term is given is un equal to 32 minus 6n. Okay, so actually for this kind of practice, you can pause the video first. I suggest that you can solve it within 5 minutes, less than 5 minutes, and then you can play the video just to check whether your working step is right or not. Okay, if it's wrong, never mind, you just do correction. Okay, you can pause the video if you want to try to do this question. Okay, for those that already try, let us check the answer. So UN is equal to 32 minus 6N, and then we start with substitution of U1. Put into it, you get answer 26, and then U2 is 20, U3 is 14, U4 is 8. So the sequence is 26, 20, 14, and 8. Okay, so this will be the first 4 terms. Okay, and then followed by find the first 4 term of the sequence which is defined by this formula. Okay, you can still pause the video, you can try first. This one you can try to make it in within 5 minutes. Okay, let us check the answer. So let's see U1, since the question given that U1 is equal to 1. Okay, so U2 is equal to 2 U1 plus 1. So you are going to use the 1 here, substitute a number from here. Why you substitute 1 from here? Because you see U1 is here. Okay, so that's why 2 times 1 plus 1 equal to 3. Okay, U3 is U2. So the answer that you found here, you have to bring forward. Okay, to 5, 7. And then U4, you get 15. The sequence is 1, 3, 7, and 15. Okay, the answer is 1, 3, 7, and 15. So please take note that the number here is always need to carry forward and carry forward to get the next value. All right, how about exercise 1C? Okay, this one start from 0 and then end with the 3. Okay, so you can see from here, if r equal to 0, u all is equal to negative 1 over 2. Where did we get this one? It's get from here. So you substitute the u all is equal to this one. You get negative 1 over 2. 1 is equal to negative 1 over 2. Okay, next one, if this one substitute with 1, we get 1 over 4. Get 2 is negative 1 over 4. So you can notice that be extra careful with the negative sign. The first one have negative, the second one is positive, the third one is negative again. Okay, be extra careful with the sign. And then the r equal to 3 is equal to 1 over 16. Okay, so when do you stop? Okay, so you will stop here when r is equal to 3, because in this formula here, show that r start from 0 and when r is equal to 3. Okay, so after you get this one, you collect, rearrange, and then everything right in this form. Negative 1 over 2 plus 1 over 4 minus 1 over 8 plus 1 over 16. So this is how you do the question that involve write down the series. Remember, this instruction is very important. Okay, how about this one? Can you compare this with the previous video, previous slide? Okay, so it means that start from R1, R2, R3, R4. Substitute into it, okay? Give yourself around maybe 3 minutes to try. Okay, if you already try, let's see the answer. So R is equal to 1, U1 equal to 3 power of 1 plus 4 power of 1. Okay, is equal to 7. Okay, R equal to 2, U2 is 3 power of 2 plus 4, 2 is equal to 17. And then when R equal to 3, you get 39. And then R equal to 4 equal to 97. And 4, this one is 4, and r equal to 1, you get this number. So 7 plus 17 plus 39 plus 97. Okay, so this is how you write in series. Okay, so here we go for the session for 1.4.1 session. Okay, so please rewind back if you need to revise on certain part of this idea. It's very important to have a very good basic so that we can move on to 4